Welcome to aminacademy.com. In physics, let us discuss about refraction of light. What is refraction? Look at here. Here, the glass of water, inside a straight pencil is dropped inside. It looks like bend. It is a reason for the refraction of the light. Refraction is the bending of light. It also happens with sound, water, and other waves as it passes from one transparent substances into another. This bending by refraction makes it possible for us to have lenses, magnifying glasses, prisms, and rainbows. Now we'll come detail in refraction. Refraction is an important term used in ray optics in branch of physics. Refraction of light is defined as the change in direction or the bending of wave passing from one medium to another due to the change in speed of wave. Due to speed of wave, light passing in different speed, that due to different medium it passes, so it is having different speed. Some natural phenomena occurring in nature where refraction of light takes place are the twinkling stars, the formation of mirage and rainbows, optical illusions, and many more. These are the natural phenomena happens due to refraction of light, that is twinkling star, the formation of mirage and rainbows, optical illusions. The major causes of refraction to occur is the change in the speed of the wave in different mediums, which is different due to the difference between the densities of the mediums. Densities changes due to change of densities, the velocity, speed of the light passing through those mediums also changing. That is, the speed of light in vacuum is maximum. Snell's law provides a quantitative description of the amount of bending of wave that depends on the refractive index of the two mediums. Now, what is refraction of light and further explanation with figure? Look at here. This is the two mediums. Here normal air medium. Here it have some other denser medium. Light incident on that separating space to that medium, and it bends like refracted medium is what. Actually it passes through straight, but it bends because of the change in densities of the two mediums. The bending of light when it passes from one medium to another due to the change in the speed of the light traveling the two different medium is called the refraction of the light. This phenomenon also occurs with the sound, water, and other waves. Because of this bending of waves that are responsible for the refraction of light, we have lenses, magnifying glasses, prisms, and rainbows. Due to this phenomenon, our eye would not be able to focus without the refraction of light. The above shown figure, light travels from medium 1 to medium 2. These mediums can be different materials or substances with different densities. So when an incident ray, medium 1 travels to another medium 2, the refracted ray bends either towards the normal or away the normal. This incident ray is towards the normal, it bends because of here higher density than incident ray. Next one, speed of light. Is the speed of light in vacuum, commonly detected as c, small c, is a universal physical constant that is exactly equal to this much meters. That is 2,99,000. This is nearly about 3 lakhs kilometers. approximately this is a 3 lakhs kilometers per second. This is very high speed. Highest speed ever known is the speed of the light. It is in miles is 1,86,000 miles per second. Now we'll talk about index of refraction. Refractive index, that is index of refraction, is a value calculated from the ratio of the speed of light in vacuum to that in a second medium of greater density. Refractive index variable is most commonly symbolized by the letter n or n days in descriptive text and mathematical equation. Refractive index n we can write as speed of light in vacuum. Speed of light in vacuum over speed of light. Speed of light in the material. Light in material medium. In material. So we can write as C over V. Next, we'll talk about Snell's law. Snell's law is defined as the ratio of the sine of the angle of incidence of to the sine of the angle of refraction is a constant for the light of given color and for the given pair of media. Look at here. Snell's law says n1 into sine theta 1 equal n2 sine theta 2. These n1 and n2 are refractive index of those mediums, and theta sine theta 1 is here, that's from this is a higher medium, theta 1 is here and theta 2 is here. This is a high denser medium, here low denser medium. So from this we can write this one as n1 by n2, n1 by n2 is sine theta 2 by also you can write from this Snell's law. Next, what is critical angle or total internal reflection? The critical angle is the angle of incidence at which a light ray changes from refracting to a total internal reflection, TIR. That means when some angle is passed, incident ray passes one medium to another, that if it is a refraction, that is its light ray changes from refracting to the total internal reflection. That means it should be a totally internal reflections happen. Then that at that position, what is the angle is called a critical angle. TIR, total internal reflection, occurs when a light ray is traveling from a denser medium to a less denser medium and the angle of incident is greater than the critical angle. At the critical angle, the angle of refraction is 90 degrees. When the angle of incident is greater than the critical angle, all light is reflected back into the denser medium and none is refracted. This is called a total internal reflection. Look at here. Here, this is incident ray. This is refracted ray. So we have to adjust the angle of incident ray here and there. Then it will give that refracted ray is like this. That means it must be perpendicular to the normal. This situation is this angle QC is the critical angle. Now furthermore we adjust this angle, that means the angle become more than the critical angle. This will not come out. That means our reflected rays will not come out of that medium here water. Only it happen inside. It's called total internal reflection. It's very interesting phenomena when diamond more glittery things happen because of the total internal reflections. Prism. Refraction through a triangular prism. A triangular glass prism has two triangular bases and three rectangular lateral surfaces. The angle between its two lateral surfaces is called the angle of prisms A. The refraction of light through the prism occurs in the way shown in the figure below. Look at here. This is here two triangular faces here and back, and three rectangular faces here, here and bottom. That means, look at here, in this, the light ray seems to bend towards the normal on entering the prism at the interface AB. This interface AB is incident ray, and from the normal it is called incident angle I, and it comes like and go back to refracted ray here. Then this angle is E, let it be E. Therefore, the angle between the incident ray produced and the emergent ray produced is called the angle of deviation. Here, this angle of, this A is angle of prism and angle D is the angle of deviation. Thus, it can be concluded that the refraction takes place at both the interfaces of a triangular prism when light passes through it. However, the refraction of light through a triangular prism is somewhat different from that of refraction through the glass slab. Here PE, what is P is incident ray and EF is refracted ray, FS is emergent ray, FS emergent ray, A is angle of prism here, and angle I is angle of incident, angle R is angle of refraction, angle E equal to angle of emergence. This angle of emergence, this angle of refraction, here angle of incident, angle of refraction, this angle of emergent. D is the angle of deviation. This is the angle of deviation. This geometry, remember this. Now, what is a rectangular slab? Let us now consider the case of refracted through a glass slab. For simplicity, sake of simplicity, we will consider a glass slab in air. Air has a refractive index of 1. When a light ray passes through a rectangular slab, it is incident on two surfaces, namely the two surfaces that are in contact with air. Here, this is surface 1, this is surface 2. Let us understand this with the help of the given diagram. This is an incident ray, this is a normal, angle I is an incident angle, this is a refracted angle from air to glass medium. Then here, it comes here, this is the incident ray to that glass 2 in glass medium, and this emergent ray is refracted ray is in air here. Here we see that the ray is incident on surface P as well surface S. As a result, two refraction occurs. Let us call this normal N1 and N2 from left to right respectively. Now we see that angle I is the incident angle and R is the refracted angle of the surface P. Since N1 is parallel to N2, these two, this is parallel, this one, normals are parallel, this here and this here, from left to right respectively. We see that I is the incident angle and R is the refracted angle at surface P. Therefore, we can say finally by using Snell's law, sin I over sin R equal to N2 by N1 and sin R by sin E, that in second medium, is N1 by N2. Therefore, in general, we can say sin I by sin R into sin R by sin E equal to 1. So, multiplying both equations here, left multiplication, right multiplication, use this equation. This was rectangular slab sin I over sin R into sin R by sin I equal 1, which means, look at here, sin I by sin R into sin R by sin A, this cut both equal 1. That is sin A by sin E. Here, next one, the difference between the refraction of light through a prism and a glass slab are as follows in table. This is through prism through a glass slab. The incident ray is not parallel to emergent ray in prism, triangular prism. Then here, glass slab, the incident ray is parallel to the emergent ray. The angle of incident may not be equal to the angle of emergent, but angle of incident is equal to the angle of emergence in this lab. The light ray is deviated from its actual path by angle d, but the light ray is not deviated but laterally shifted. Yeah. So far we discussed about refraction of light in different ways. We have done. Please subscribe our YouTube channel.